Okay, we ended our last video talking about this problem, right? We found all the characteristics that we were looking for, and then we graphed. And so this brings us to our first classic problem for you, 2.2.1. You are going to do the same thing that I did, but you're going to do it for this problem. So y is equal to x squared plus 10x plus 21. Direction of the opening, axis is symmetry, vertex, minimum, maximum value, y-intercept, x-intercepts, and then draw the graph. All right. So you can pause here, and then I'm going to move on. So let's take a look at vertex form. We're going to go through the same thing that we just did for standard form. I'm going to walk you through finding all the characteristics. All right, so vertex form is in the form y is equal to a times x minus h squared plus k. So this is the a, h, and k format that I need for you to become familiar with, that we've have talked about in the first chapter. So direction of the opening, again, if a is greater than 0, it's up. If a is less than 0, it's down. I should say if a is greater than, I am not going to say equal to 0, because then it wouldn't be an equation. But so this, if there's no number here, it's going to be 1. So if a is greater than 0, it's up. If a is less than 0, it's down. Remember, a cannot be 0. All right, so we see that the graph opens up because this value of 5 is greater than 0. And then we're going to find the vertex. So it's called vertex form because we can get the vertex straight away from the form. And it's in h and k form. So h is -4, k is -5, my vertex is -4, -5. All right, so I'm piecing together the puzzle of the graph, which we're going to graph. All right, so next, I think I skipped something. To find the minimum and maximum value, we're going to see directions for, see the direction of the opening, and then we're going to use a y value. So we said the vertex was -4, -5. The minimum value, because it opens up, it's a minimum value, not maximum, is going to be -5. So minimum is -5. Then we will find the axis of symmetry. Axis of symmetry is the line that goes to the vertex. We already found the vertex. We know that the value for x is the same for the vertex and the axis of symmetry. So x is equal to -4 is the equation for the axis of symmetry. And then this is just kind of a look at how things are with the axis of symmetry. Right? We talked about this vertex. Axis of symmetry goes through the vertex. And then just a heads up, in pre-calculus, you'll start to talk about parabolas open right or left, but not in algebra 2. All right, now we're going to find the y-intercept. We're going to set x equal to 0 and solve. And to find the x-intercepts, we're going to set y equal to 0 and solve. And so to find the y-intercept, we set x equal to 0. 0 plus 4 squared is 16. 16 times 5 is 80. 80 minus 5 is 75. And then to find the y-intercept, we're going to set y equal to 0. 0 is equal to 5 times x plus 4 squared minus 5. I'm going to add 5 to both sides, then divide by 5 here. Take the square root of both sides. And then solve 1 is equal to plus or minus x plus 4. I'm going to solve for x using my algebra skills. And I end up with x is equal to -3 and -5. All right, so x-intercepts are going to be -3, 0, and -5, 0. All right, so I have all the data here. And then I'm going to use this information now to graph. My vertex -4, -5. The two x-intercepts -5, 0, -3, 0. My y-intercept 0, 75. My minimum value is -5. My domain is all real numbers. Again, my range, I have a minimum value, so that minimum value is -5 to positive infinity. It's decreasing from -infinity to 5, and then increasing from -5 to infinity. And so when we talk about where it's increasing or decreasing, we're using the value of x. Okay, so it's decreasing from -infinity to, so I had to correct my error here. I had intervals with the y values, but The interval for decreasing and increasing is on the x-axis. So I'm decreasing from negative infinity. See, it's decreasing here from negative infinity to 4. And then at 4, x is equal to negative 4, excuse me, then it increases again. So I had to adjust these numbers here for decreasing and increasing. All right, so this brings us to classwork 2.2.2. I'm going to show you this problem. So you're going to, in vertex form, you're going to provide all this information. You're going to graph the function. So 2 times x minus 3 squared minus 2. I'm going to pause here, and you guys can write this down, and then we're going to move on. Okay, so last part of this is intercept form, second section. So remember I said there's a lot of information. Intercept form, y is equal to a times x minus p times x minus q. Same thing here. I'm going to find in this order this information. So let's walk through this. Intercepts, direction of opening, axis symmetry, vertex, maximum, minimum, and then to find the y-intercept. So the intercepts, a times x minus p times x minus q. So the a value is 2, and then I'm going to find my p and q here. I'm already basically given in factored form the quadratic. So my 2x intercepts are negative 4, 0, and 2, 0. The values that make, so the values of x that make factor equal to 0. All right, so that's A. B is a direction of the opening. 2 is a positive value. It opens up. Axis of symmetry is the midpoint between these two x values, right? Because we said that the axis of symmetry splits the parabola in half. If I have these 2 points on the x-axis, negative 4, 0, and 2, 0, I can find that midpoint on the x-axis. So negative 4, and this is your midpoint formula, plus 2 divided by 2. Negative 4 plus 2 divided by 2 is equal to negative 1. X is equal to negative 1 is the axis of symmetry. All right, to find the vertex, we're going to use the x value in the axis of symmetry. So remember my, if we have a visual on this, well, maybe we'll go back to, my axis of symmetry goes right through the parabola. So if I have the axis of symmetry, I can find the x part of the vertex, and then I can use that to solve for y. All right, so I have the axis of symmetry. X is equal to negative 1. I'm going to substitute that back into the function. So x is equal to negative 1. And then I'm going to solve for y. Y ends up being negative 18. So now I have x is equal to negative 1, y is equal to negative 18. That's going to be my vertex. I know that the parabola opens up because it's positive. So this value for 18 is going to be, negative 18, is going to be my minimum. The minimum value is y is equal to negative 18, or just negative 18. All right, so to find the y-intercept, we're just going to set x equal to 0. Very straightforward. X is equal to 0. X is equal to 0, and solve. We end up with 0, negative 16. All right, so I have all the information now I need to graph. I have the 2 x-intercepts. I have the y-intercept, I have the vertex. I have my axis of symmetry. Goes right through the vertex. X is equal to negative 1. My minimum value is negative 18. The range, all real numbers. Domain negative 18, which is my minimum, to infinity. My intervals, it's decreasing from negative infinity to negative 1, and then increasing from negative 1 to infinity. All right, this brings us to classwork 2.2.3. I'm going to show you this similar problem, and you're going to do exactly what I just did. And you're going to find all this information. You can pause this here, and I am going to move on. Okay, last part is we want to solve real-life problems. Right, so here's an example of a real-life problem. The parabola shows, this first parabola shows the path of your first golf shot. So I hit a golf ball, it travels in the arc of a parabola. Second golf shot is modeled by this equation, which is really just intercept form, because I can say this is minus 0.02 times x minus 0 times x minus 80. Okay. Where x is the horizontal distance in yards and y is the corresponding height in yards, which shot goes the furthest? All right, so I'm going to evaluate the second shot. I see that it's just the same as an intercept form, so I have my two x-intercepts at 0, 0, and 80, 0, where this is the ground, the x-axis. And it intersects the x-axis at 80, 0. So the second shot is shorter because the second shot travels 80 yards and the first shot travels 100 yards. Okay, this brings us to your classwork problem. 2.2.4. And a soccer player kicks a ball downfield. The height of the ball increases until it reaches a maximum height of 8 yards, 20 yards from where it was kicked. Second kick is modeled by the function below. Which kick goes the furthest? Which goes the highest? All right, that brings us, I believe, to the end of this lesson. And thank you very much for joining us. There are definitely a lot more real-life applications for this, which we'll review in subsequent sections. Thanks very much.